Hello and welcome to our lesson on adding and subtracting fractions. So adding and subtracting fractions requires that the fractions be like fractions. So what does that mean? Well, fractions with the same denominators, also known as common denominators, are what we call like fractions. So in order to add and subtract, we want to be looking at like fractions. We want to be looking at fractions that have the same denominators or common denominators. And if we have that, then to add those like fractions, we simply add the numerators. If we add our numerators, we keep our common denominator, we're going to end up with our answer. So we add the numerators and we write that sum over that common denominator. So for instance, you can see in this picture here, if we were trying to add 1/5 with 2/5, well, what does 1/5 look like? Well, here's your picture of fifths. One of those would be the one shaded in, right? Or 2/5. Here's your picture for 2/5. You have 5 total and the 2 that are shaded. If we wanted to add those, 1/5 here, transferred down, 2/5 here, transferred down, gives us 3 of those fifths all together. Okay? So when we are adding, we need those denominators to be like, and if they are, we are simply going to add our numerators and keep our common denominator. So if you can see the algebra here, the 5 doesn't change. We keep that common denominator. If we add our numerators, 1 plus 2 makes 3. Okay? So in general, when we are adding fractions that have common denominators, you would have something like a over c plus b over c. If our denominators are going to be the same, we're going to keep that common denominator and then just add our numerators. So the a plus the b in the top of the fraction. So in general, that's really sloppy, that's how that looks, okay? So if you're adding a over b, I said a over c plus b over c, then you're going to have a plus b over c. Okay? And fortunately for us, subtraction works basically the same way. If we are going to subtract like fractions, then to subtract like fractions, we subtract the numerators. And again, we're going to keep that common denominator the same. So for instance, if I have 6/7 and I want to subtract 2/7, what would I have left? Well, here's your 1, 2, 3, 4, 5, 6 of those sevenths. If I wanted to take, let me go back. If I have 6/7, if I wanted to take 2 of those away, take 2 away, what we have left is 1, 2, 3, 4 of those sevenths left. Okay? So again, we're going to keep that common denominator, the 7's not changing, and we're going to subtract our numerator. So 6 minus the 2 gets us the 4. And there we have it. So in general, if we have something like a over c, and we wanted to subtract b over c, then we're going to be left with a minus b over c, where the denominator doesn't change and we simply subtract those numerators. Okay? So let's look at a few more. Let's say we wanted to add 2/7 and 3/7. So this is going to be 2 plus 3 in the numerator, and we keep our common denominator of 7, and 2 plus 3 is 5, so 5/7 is our result. Okay, or here, we have 3/16 and 7/16. So this is going to be 3 plus 7 in the numerator. 16 is our common denominator that we keep. And 3 plus 7 is 10, so we end up with 10/16 here. Now we do need to make sure, and this is true for any operation, we've seen this in the past, that our answer, in this case our sum or our difference, should be written in its simplest form. And I feel like I should have had a bullet for that, and I forgot. Okay, well. So we want this to be in simplest form, and I can see that 10 and 16 both have a common factor of 2. So if I divide by 2 here, and I divide by 2 here, to take this little shortcut for reducing, 10 divided by 2 is going to be 5, and 16 divided by 2 is going to be 8. So 5/8 would be my final answer for that one. Okay, so that was adding. Subtracting works the same way. So here we're going to be looking at 8 minus 1 in our numerator, and then we're going to keep our common denominator. And 8 minus 1 is 7, so 7 over 9 is going to be the final difference. And here the same thing. This is going to be 7 minus 5 in the numerator. Common denominator of 8 is not going to change. Now 7 minus 5 is 2, so we end up with 2/8 here. But again, we have a common factor. I can see that 2 goes into each of these. So I'm going to divide the top by 2. I'm going to divide the bottom by 2 to use my little shortcut for reducing. So 2 divided by 2 is 1, and 8 divided by 2 is 4. And remember, if you don't like the shortcut for reducing, so I have 2 on the top. If I wanted to rewrite the 8 as 2 times 4, and then reduce the 1s from there, you can, to whatever method you're comfortable with. Okay? And let's try this last one, where we have some addition and subtraction. This is fine. We're going to keep our one common denominator of 12, and then just perform these operations that they're asking us in the numerator. So we've got 10, and then we have a plus 1, and then we have a minus 3. So we're just going to go from left to right. 10 plus 1 is 11, and 11 minus 3 is going to be 8. So we end up with 8/12. But again, we've got a common factor here, and this time I could see 4 goes into both of these. So let me reduce by dividing both numerator and denominator by 4. 8 divided by 4 is going to be 2, and then 12 divided by 4 is going to be 3, and so 2/3 is our final result. Okay, and then while we want to be proficient in doing these things without technology, we can by all means use technology to confirm our answers. So 10/12 plus 1/12. And then let's say we wanted to subtract 3/12 just to be safe. We type all this in, and Desmos gives us 2/3 as a final simplified form of the answer. Okay? So you can verify whatever you're doing with the calculator. All right, now adding and subtracting like fractions is pretty straightforward. However, not all fractions are like fractions. But before we can add or subtract fractions that are not alike, we need to be able to find what we call a least common multiple for a set of numbers. And least common multiple will be abbreviated LCM. So a least common multiple of a set of numbers. So what is a least common multiple? Well, least means smallest, and then a common multiple is the smallest multiple they have in common. Or we could say it's the smallest number that every number in that set divides into evenly. Okay? There are two ways to find, well, two ways I can think by hand to find a least common multiple. Also, technology can help us with this, but we can find our least common multiple by just making a list of multiples. So by listing our multiples and then finding the smallest one they have in common, or using prime factorizations. So I'm going to show you both ways, and then I'll also show you how to do this in Desmos. And again, we want to be proficient by hand, but having the technology to rely on is also a nice thing. Okay, so let's say we wanted to find the least common multiple for 6 and 8, and we're just going to list out multiples to do this. Multiples of 6 means multiply 6 by our natural numbers. So 6 times 1 would be the first multiple. 6 times 2 would be the second multiple. 6 times 3 would be the third multiple, and so on. So 6 times 1 is 6, and 6 times 2 is 12, and 6 times 3 is 18, and 6 times 4 is 24, and 6 times 5 is 30, and that's my list of multiples there, and it can go on forever, but I'm going to stop there, and I'm going to start my next list. I'm going to list out my multiples of 8. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32, and again, this list will go on forever, but the purpose of making this list is to find the smallest multiple they have in common. So in our list of multiples, we're looking for one that's the same and the smallest one that's the same. So in this case, you'll notice that both have a common multiple of 24. That happens to be the least common multiple for these two numbers. So here, we're going to say our least common multiple is 24. That is the smallest number that both 6 and 8 divide into. Okay? Let's try that again. Let's list out multiples for 15 and multiples for 50 and multiples for 50. Okay, so 15, let's see. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. 15 times 5 is 75. 15 times, where am I at? 1, 2, 3, 4, 5, 6 is going to be 90. And then 15 times 7 is going to be 105. And then 50, oh my gosh, this is going to be a long list. Why am I continuing this list so far when I didn't continue the other one so far? I'll tell you in just a second here. So this other one, I stopped my list because when I was making my list of multiples for, oops, that's my eraser. When I was making this list of multiples and I saw the 24, I knew that 8 went into 24, so I could stop my list there, okay? So far in making this list of multiples for 15, I haven't seen anything that divides by 50. So I'm going to keep making the list, and hopefully we're going to get there. So 1, 2, 3, 4, 5, 6, 7, that's for 7 multiples. 15 times 8 is going to be 120, and then times 9 will be 135. And then times 10 is going to be 150, and I can stop there because my multiples of 50, 50 times 1 is 50, 50 times 2 is 100, and 50 times 3 is going to be 150, so that's going to be the smallest multiple they have in common, or the least common multiple. So the least common multiple here, that was a fun one, right? Least common multiple here is going to be 150. Alrighty, so that is one option for finding our least common multiple. It's not necessarily the most efficient way to do it, although if you were going to find the multiples that way, it might be easier to start with the larger number, because obviously we got to that common multiple a lot faster on that list of 50 versus the list of 15s. So start with the larger number if you want, until you know you have a number that 15 is going to divide into, or vice versa. Now, there is another way. I don't know if it's any more efficient, but the other way is to use prime factorizations. So let's say we take 60 in this example and break it down into its prime factors. So 60, for instance, is 6 times 10, and then 6 can become 2 times 3, and then 10 can become 2 times 5. So I would say my prime factorization here would be 2 squared times 3 times 5. And then if I make my prime factorization for 72, 72 I know is 8 times 9. 8 I could make 2 times 4. 4 I could make 2 times 2. And then 9 I could make 3 times 3. So my prime factorization here, I would say, is 2 to the third power times 3 to the second power. Now once you have your prime factorizations, to find your least common multiple, you're going to look for any factors in those prime factorization lists and the highest exponents you see with them. So both lists have factors of 2's, but the higher exponent, the highest amount of 2's I see, is 2 cubed. So 2 cubed is going to be part of my LCM. Both lists have 3's, but this one has more 3's, so I'm going to circle that. And then one of this lists has a 5, so I'm going to circle that. And that's it. So I don't have to circle this 3 because I already took care of 3's over here. I don't have to circle the 2's here because I took care of 2's over here. So I need any factors that occur, and then I want the ones that have the biggest exponents, that occur the most amount of times. Now my LCM will be a product of those. So 2 cubed times 3 squared times 5 is going to be my least common multiple. So 2 cubed, 2 to the third, times 3 squared times 5 means my least common multiple for these two numbers is 360. And it might have taken a little while making those lists to find that. So this is an option 2. Now this option is a little more complicated, so let's try that again, okay? Let's find the prime factorization of 12. So 12 is 2 times 6, and 6 is 2 times 3. So I could say my prime factorization is 2 squared times 3. And then for 20 I could say is 2 times 10, and then 10 is 2 times 5, so my prime factorization here is going to be 2 squared times 5. So any factors and their biggest exponents. So since there are 2's occurring in here, I'm going to have 2's in my LCM, and they both have the same exponent, so either one I can circle is going to be fine. I see a 3, I see a 5, and those are the only exponents I see with those. So those numbers tell me my LCM has to be 2 squared times 3 times 5. And 2 squared is 4, 4 times 3 is 12, and 12 times 5 is 60. So my least common multiple for 20 and 12 is going to be 60, okay? Now I know you may not be liking that method at all, which is totally fine. Well, let me just make a little note here. So you're circling any factors, any factors that occur, and let's see, how can I say this concisely? Any factors that occur and the highest exponents that occur with them. Any factors and, why can't I draw this and symbol? Sorry. And their highest exponents. Okay, and then we take the product of those things we circled to get the least common multiple. Now, if that's still not making sense to you, it's okay. You don't have to use the prime factorizations to find least common multiple. You can list out the multiples, or you can use technology. Okay, now again, we want to be proficient doing these things without the calculator, but if we have technology, right, let's use it to at least verify what we're doing. So in Desmos, if you go to Functions, see the little option over here to go to Functions, and then go to Miscellaneous, you're going to see LCM right here. So if you hit LCM, and then you type in like 60, 72, it'll say the smallest number they both go into is 360. Or if you wanted to look for 20 and 12, put those in and it tells you it's 60. Okay, so you can also use your technology to do this. All right. Now, one other skill we need before we can add or subtract unlike fractions is writing equivalent fractions. So this is going to be the reverse of something we've already done. We have seen how we can reduce a fraction, how we can simplify a fraction by dividing out common factors, and what we get is an equivalent form. So we just saw this a bit ago, actually, like this. Okay, when we took the 8/12 and we divided it by 4 to get 2/3, we simplified it, but we know that 8/12 and 2/3, those are equivalent fractions. They look different, but they have the same value. Okay, so what we're going to be doing here is working in reverse. Instead of dividing out our common factors, we're going to multiply them in to make an equivalent form. So instead of going from 8/12 down to 2/3, we're going to be starting with something smaller, and we're going to multiply to make it bigger, but we're still dealing with equivalent fractions. Okay, so we can also multiply a fraction to write it in an equivalent form. And remember, when you multiply, you want to maintain the original value of your fraction. And so in the same way when we were dividing, we divided the top and the bottom. We want to make sure we multiply the top and the bottom, because when we multiply a number by 1, that is the only way to maintain its value. So if I multiplied by, let's say, 4 over 4, that's really 1. Or if I multiplied by 5 over 5, that's really 1. So when we multiply, we have to make sure we multiply the top and bottom of our fractions. Okay, so let's look at an example. If we're asked to write 1/3, which is in its simplest form, as an equivalent fraction with a denominator of 12. Okay, if I have 1/3 and I want to make it an equivalent fraction where the denominator is a 12, what do I have to do? Well, think about what we're doing to go from 3 to 12. Okay, to go from 3 to 12, I have to multiply by 4, so I want to do the same thing on the top. To go from here to here, I have to multiply by 4. And what's 1 times 4? Well, that's going to be 4. So 1/3 is equivalent to 4/12. So 4/12 is my equivalent fraction. Okay? Or similarly here, it says to take 2/9 and write it in an equivalent fraction with a denominator of 27. So to get from 9 to 27, I'm multiplying by 3. So I want to do the same thing in my numerator. Multiply by 3. And 2 times 3 gives me 6, which means the equivalent form is going to be 6 over 27. It's not so bad, right? So just like dividing, but in reverse. Instead of taking the unreduced form and dividing to get it to the simplified form, or taking a simplified form and multiplying to make an equivalent fraction that isn't in its simplest form. But that's going to be a skill that we can use for unlike fractions. So when we're dealing with unlike fractions are fractions with different denominators. If our fractions have different denominators, they are called unlike fractions. And to add or subtract fractions, we have to have common denominators. We have to have like denominators. So for instance, let's say we're looking at 3/4 and we want to add 1/6. So picture-wise, what does that look like? Well, we know 3/4, 1, 2, 3 shaded region of 4 total. If we took the same size of an object here and cut it into 6, there would be the 1/6, right? If I want to add those, what does that look like? Well, I can't just add these two amounts that are different. They're not like terms, are different terms. Like, what does that 1 and that 1 look like? Well, I can't say that's 1 of the 4ths plus 1 of the 6ths and call it 2 of the what's. Do you see what I'm saying here? They have to be in like terms in order for us to actually put them together. So what we would do is we would take 3/4 and make an equivalent fraction out of it. So 3/4, for instance, is going to be equivalent to 9/12, right? We see how these 9 out of 12 represents the same thing as these 3 out of the 4. So those are equivalent. And 1/6 here is equivalent to 2/12. So if I cut that same grid into 12, those 2 would be the same as the 1. Okay? Well, now that they're both in 12ths, I can see exactly what I'm putting together. If I have 9 of them here and 2 of them here, then I have 11 of those 12ths all together. So the 11 of the 12ths is going to be my answer. All right? So the goal when we're adding our fractions is to get equivalent fractions, right? Get like denominators. So what we would be looking for is the least common denominator, or the least common multiple of our denominators. So looking at our denominators 4 and 6, the smallest number they both go into is 12. So the goal was to get 3/4 to be an equivalent fraction with a denominator of 12, and to get 1/6 to be an equivalent fraction with a denominator of 12. So 3 times, since we're multiplying 4 times 3, we do 3 times 3 as well to make the 9 here. And since we multiplied 6 times 2 to get 12 here, it's going to be 1 times 2 to get 2 here. And then once we have our like fractions, this is just like what we were doing a few minutes ago, we can keep that common denominator and add those numerators. And the same will work with subtraction. So if we're adding or subtracting unlike fractions, we have to find the least common denominator, the LCD, least common denominator, which is the least common multiple for our denominators. And then we're going to write each fraction as an equivalent fraction whose denominator is the LCD. And as we saw a few minutes ago, we have to multiply to make that happen. And then we can add or subtract the like fractions that we've created. And then just be sure that that final sum or difference is in its simplest form. Okay, so let's try this out here. If I want to add 2/5 and 4/15, I can't unless I have like fractions. So the first thing I need to do is find my least common denominator, which is a common multiple for 5 and 15. So I'm going to use my listing out of multiples, and I'm going to start with the bigger number, the bigger denominator, which is 15, and just start listing them out. Well, 15 times 1 is 15, and I already know 5 goes into that. So 5 can be my least common denominator. So my least common denominator here is 15. So my first fraction is already out of 15. I don't have to change my first fraction. But my second fraction, I need to have a denominator of 15. So how do I make... I'm trying to organize my work here, and it's not really working for me. Least common denominator. So I need to make my second fraction have a common denominator of 15. So how do I do this? I'm trying to organize this nicely for you here. So here, I want 2/5 to... I said fifths and I wrote 15ths. I want 2/5 to be an equivalent fraction with a denominator of 15. So if I have to multiply 5 times 3 to get 15, then I have to multiply 2 times 3 to make 6. So 2/5 is equivalent to 6/15. So when I rewrite this problem, 2/5 becomes 6/15, and now I can add to that the 4/15. So this became that, and I showed you the work, and this didn't change, okay? But now that we have like fractions, we can put them together. So this becomes 6 plus 4 over 15, which is 10 over 15. And I can see a common factor of 5 here. So if I reduce by 5, divide by 5, then my final result, 10 divided by 5 is 2, and 15 divided by 5 is 3. So final result is going to be 2/3. Okay? It's a lot more work than when they're not like, right? So let's try that again. So least common multiple for 7 and 3. If I started listing out multiples of 7, 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. Well, 3 goes into 21. So my least common multiple is going to be 21, which means my least common denominator is going to be 21. So I need both fractions to have a common denominator of 21. So how do I make 2/3 an equivalent fraction with 21 as its denominator? Well, I had to multiply by 7 to get to 21 here, which means I'll do the same thing on the top. Multiply by 7 to make 14. And then here, how do I make 1/7 an equivalent fraction with a denominator of 21? Well, I have to multiply by 3 here, which means I've got to do the same thing on the top and get 3 here. So it's going to be 3 over 21. So my problem is really what is 14 over 21 plus 3 over 21. Okay? Now that's a lot of side work, and it's totally okay to do all that side work, but I just want to show you another route here for organizational purposes. If your common denominator is 21, you can see to get from 3 here to 21, I'd have to multiply by 7. So let's take this first, giant eraser. Let's take this first fraction and multiply it by 7 over 7, which gives me 14 over 21. And let's take the second fraction and go, what do I have to multiply to get from 7 to 21? Well, that would be 3. And so let's multiply by 3 over 3, which makes it 3 over 21. And now I have my like fraction. So it's just another way to organize the work. I think it's a little less to look at. So if you can wrap your brain around doing it this way, it's going to probably make your life easier. So over here, it's going to be 14 plus the 3 over now the common denominator of 21, and 14 plus 3 is 17, and so 17 over 21 becomes our answer. Okay, let's try this again. So 9 and 12, I need a common multiple for. I'm just going to start listing out multiples of 12 until I find something 9 goes into. So 12 times 1, times 2, times 3. Oh, there it is. 12 goes into 36, and so does 9. So 36 is going to be my least common denominator. So my least common denominator is going to be 36. To get from 12 to 36, I'd have to multiply by 3. So I'm going to multiply by 3 over 3 here. And to get from 9 to 36, I have to multiply by 4. So I'm going to multiply by 4 over 4 here. That gives me 33 over 36 to subtract, and then subtract 8 over 36. And now we have our like denominators. So this is going to be 33 minus 8 divided by 36. And then 33 minus 8 is going to be 25. And 25 over 36, there are no common factors for, so 25 over 36 is my result. And again, your calculator can confirm this, so let's just... And even if you just wanted to do the least common multiple, remember your calculator will tell you the least common multiple for 12 and for 9 is 36, or it'll do the whole problem for you, right? 11 over 12, let's subtract 2 over 9 and convert that to a fraction, and there it is, the same answer that we just got. Okay? So this is good practice, but we have calculators that can help. All right, so let's go here. Multiples, least common multiple for 15 and for 10. Let's try the other approach this time. If I took 15 and broke it down, it's 3 times 5. If I took 10 and broke it down, it's 2 times 5. So a 3 and a 5 and a 2, and that's it. So 3 times 5 is 15 times 2 is 30 for my least common multiple. If you like that way. If you don't like that way, 15 times 1 is 15, 15 times 2 is 30, and then I stop there because both 15 and 10 go into 30. Okay, so least common multiple is going to be 30. So to get from 15 to 30, I'm going to multiply by 2. And to get from 10 to 30, I'm going to multiply by 3. So I'm looking at 22 over 30. And I want to subtract 9 over 30. And 22 minus 9 is going to be 13. Did I skip that step there too? No, I didn't. Okay, sorry. So this is going to be 22 minus 9 over 30, and 22 minus 9 is 13. So 13 over 30, nothing in common. That's going to be the result. All right? I got one last one with 3 fractions in it, so I need something that 6, 2, and 3 all divide into. So let me start with the biggest number here, which is 6. Well, 6 goes into 6, and so does 3, and so does 2. So 6 is going to be my least common multiple for all 3 of those. So my least common denominator is going to be 6. So my first fraction, to go from 2 to 6, I'd have to multiply by 3. My second fraction, I have to go from 3 to 6, so I'm going to multiply by 2. And now I can't fit this here, so let me rewrite this. I'm going to have 1/2, plus I'm going to have 2/3, minus I'm going to have 5/6. So I said again, to get from 1/2 to 2 to 6, I have to multiply by 3. To get from 3 to 6, I have to multiply by 2. And to get from 6 to 6, I'm already there, don't have to multiply by anything. And so I'm looking at 3 over 6 added to 4 over 6. And then from that, we're going to subtract 5 over 6. So the result will be 3 plus 4 minus 5 over 6. And 3 plus 4 is 7. 7 minus 5 is 2. So 2 over 6. But that can be simplified. If I divide the top and the bottom by 2, I end up with 1 over 3 for the final result. Okay, so there it is. all of that can be confirmed with the calculator. Definitely a little trickier than adding when we already have like fractions, but I think you have enough now to get going on that practice. So give it a try, and as always, if you find yourself needing some extra help, then please reach out. Until next time, take care.